Okay, having a look at question 14 from the Tech Active 2024 Maths Methods paper. So we've got a football coach offered a 12-day intensive training clinic. During the clinic, the height that each player could kick a football was monitored. One player's kick heights could be modelled as, and then they've got the equation there, where h is the vertical height in meters and t is the time of days spent in training. Determine the initial height that the player could kick the ball. Now remember, Tech Active, we can use our calculators. So I'm going to my y equals, I'm going to put in that equation there. So log 10x plus 10 bracket plus 5. Hit my graph there. Obviously I'm going to have to change my window because I was working on a different type of question. Obviously we're going up to 12 for 12 days. Our height maximum, I'm going to put 20 and we've got our graph there. Now we want to know, determine the initial height that the player could kick the ball. So our second trace 1, we're putting x equals 0 and we get y equals 6. So we do need to write what equation we would use for that. Log 10t plus 10 plus 5, and that would equal 6 meters. And from calculator, for 1 mark there. Determine the training time needed for the player to be able to kick the ball to a height of 7 meters. So we can go back to our equations there, put in a 7, that'll graph that one in there. We can then do the intersect and get our intersection at x equals 9 for that one. So x equals 9 meters for when that works. Now we could also put what we did to calculate that one, but it's in the marking scheme, it just says using your calculator, so you don't have to show any working out for that. Up here we did have to put that we were working out our h, sorry I should have written 0 there, that's like a 6, to get that answer. Then we've got determine the overall improvement in kick height achieved by completing the clinic. So the clinic is 12 days, so we want our height at 12 days. So going back to our calculator, I'm going to take that 7 away. Got my graph there. I'm going to do the second trace value at 12. That gives me 7.1139. For that, I already know my height of 0 is 6 from the first question. So my improvement is going to be the 1.1139 for that. So that's the overall improvement. Then it asks you for the rate of change in kick height when t equals 1.5. Now we're on our calculators, so that makes it a bit easier. So I'm just going to do second trace. I've got my derivative there, so I can just do that and put in the 1.5 for finding the derivative at 1.5 days, or what the value of that is. So you can see up the top here, it's telling me that is 0.17371. which we'll, and rounding up that to 2. And that is the, would be the h dash of 1.5. And we've got that from our calculator. It's another 1 mark question. We don't have to find the derivative. Then it says determine the training time as a decimal when the rate of change in kick height is 0.09 meters per day. So again, let's use this graphics calculator to its potential. Get rid of that equation there. We're now going to put in the derivative. So if we press math, we can go to, whoops, I should have gone the other way. Here's our end derivative. We're now able to put that derivative in. So we want d on dx. We want to type in that original equation. So our log of 10x plus 10 bracket plus 5 end bracket when x equals, just put x equals x, graph that. I may need to change my window if I can't see that. I should be able to have enough on there, I think. We want to find when it's 0.09. So I'm going to now pop 0.09 in there, graph that, and then I should be able to find when those two lines intersect. I could change my window if I wanted to see that a little bit more clearly, but I can see on my calculator that that is then going to be at x equals 3.82549. Now they've told us to leave that as a decimal, so that would be And we can change that to a T if we want there, 3.82459 days from graphics calculator. And that was the end of question 14.